that means maximum minus minimum. So I think it's like when you are taking the three numbers. We just need to sort all it. We just need the output of minimum of error back from I of 0 plus I of 1 minus I of 0. Yeah. Problem B. With the odd box of tiles whose painted marks have begun to fade. So before she can put it away, spread the tile across the dining table and turn them into a puzzle. There is a row of n tiles. Each tile should be marked either with 0 or 1. Rows of n tiles. Okay. However, some of the marks have faded away, so the current row is represented by 0 and question mark. Both the must replace every this with this. After replacement, the two neighboring tiles SS form a domino of weight S of I plus S of I plus. Note that two consecutive dominoes share exactly one tile. Okay, like, yeah, that's true. The complete row is valid if two consecutive dominoes have different weights. Different weight. Okay. Different weight. Determine the number of ways to replace all this. So that okay. Complete row is valid out with the number one doing this. Let me be sure about the problem statement. Odd box of tiles. Old box of tiles whose painted mark have begun to fade. Okay. Can put it out. Okay. I've already spread the tiles across the dining table and turned them into a puzzle. There are n rows of tiles. Let's read this. Some of them are spread away. So this. Two neighboring tiles, Si and Si plus 1. So form a domino of weight this. So weight of the domino can be either 0 and 2. So two consecutive dominoes share exactly one tiles. That's true. The complete row is valid if two consecutive dominoes have different weights. Okay. So here in the first case, the one domino, there is only on dominoes, so every operation is valid. That's right. In the second case, the valid dominoes are 0, 0, 2. Okay, consecutive cannot be seen. So let's see, like in a consecutive element, like if there is a 0, 0, then there can be 1, 0, 0, 0, 0, 1 is valid, 0, 0, and then 1, 1 is valid. So these four are valid. Which are not valid? 1, 0, 1, 0. This is not valid. Not valid. Then 0, 1. Yeah. It's not valid. So number of ones in the left and right must differ. Sorry, I made it wrong. It will be 1, 0 line. So this is not valid. When it is not valid? When it is not valid, if the left and right character are same. So for a particular SI, if S of I minus 1 and S of I plus 1 are same, then not valid. So I think we just need to keep track of this element, so that when we are placing this element, we ensure that we are not putting any invalid elements. So I think it's enough to do a DP. So DP of 2e5 plus 5 and DP of n. And the last. So last can be, there's two options. There's 0 or 1, right? Okay. I, so far what we have, and the last. Let's see the scale. If I equal n, then we are done. If I equal n, then we are done. I'm going to plus 3 here. If dp of I and L is not equal to minus 1, return dp of I of L. Now rate is equal, this is 0. Now if s of I equal question mark, then we have the possibility to do either plus 0 or 1. Otherwise we check if L equal wait. We need to keep track of both, like last and second last. This is the second last and this is the previous last. So L2 and L1. Later we just return the dp of I and L2 and L1 into rate. Okay. So dp of I of L1 and L2 minus 1. So now if this is fixed, now if L2 is basically equal s of I, s of I minus this, then we cannot place anything. If it is not equal, then only we can do this. That means red plus equal, not exactly plus, we need to do the modular arithmetic, where we just need this. So go of I plus 1, L1 become L2, this become s of I minus 0. Right? This is one of the valid. And we have two options. Either plus 0 or plus 1. So when it is possible to place 0, if L2 is not is equal 0, then we can place, then self rate will be rate comma go of I plus 1 alone and s of I minus this is 0. Then the same thing, if L2 is not is equal 1, then self add rate and go of I plus 1 comma alone comma 1. I think that's it. 4 to 1. Did I do a mistake? I think it's fine. Very straightforward. Hot potatoes and the fairy virus. So on the part of the virus, so first game view. There are 2n leprechauns sitting on a circle. There number from 1 to 2n profiles. They are divided into two teams. So leprechauns with odd numbers belongs to the red team, even numbers belongs to the blue team. Even numbers belong to the blue team. Initially, some leprechauns hold a potato. The game then lasts for k rounds. At the beginning of this round, both teams know the current position of all potatoes, then simultaneously every who is holding a potato does exactly one of the following. Keep the potato or pass the potato to the next leprechauns clockwise, provided that the next leprechauns does not hold a potato at the beginning of the round. If the next, well, I'm becoming confused. n and k, the half number of the electrons, and the number of rounds. The second is a binary string of 2 elements describing the initial state of the game. This is 1. Then I initially holds a potato, otherwise they not. Okay, we need to print 20 is like the score of the red team and blue team in the plot. Okay, let's see now. Let's read it again. So there are 2 1. What is this? What is this? Reverence is solitary god. Supernatural beings. What? Irish legendary creature. What's this? Okay, sitting in a circle. In a clockwise order. They are divided into 2 teams. The odd numbers are red team. So we just say the odd team and even team. So initially some of them hold a potato. So I think, yeah, if this is equal 1, that they hold a potato, otherwise they're not. Initially, okay, the game lasts k round. K is also given. At the beginning of this round, both teams knows the current position of all potatoes. So both the team knows where the potatoes are. Then simultaneously every of them holding a potato does exactly one of the following. So who is only holding the potato, they can do exactly one of them. So either they keep the potato or pass the potato to the next replicants clockwise, provided that the next replicant does not hold a potato at the beginning of the round. What? Next? Provided that the next one does not hold. Okay. So like if the next one do not hold any potato, then someone can basically pass that potato to that. Okay, if the next replicant holds a potato at the beginning of the round, the current holder must keep their potatoes. Whether a potato can be passed depends on only the position of the potatoes at the beginning of the round. Under these rules, okay, this is an important distinction. Like whether a potato can be passed depends on only the position of the potatoes at the beginning of the round. So it's not like someone is passing a potato and then this place become empty, so the one who is before that empty place can pass through. No, that is not possible, because that's this determined or depends at the beginning. So under these rules, every of them hold at most one potato at any time. So when all k rounds are over, the final bell rings. Every of them still holding a potato is eliminated from the game. What? Okay. The score of each team is defined as the number of eliminated. Is defined as the number of eliminated players on the other team. On other team, all members of each team cooperate and share all available information to maximize their teams. Find the score of the odd team and even team. If both play optimally, it can be shown that the score under optimal play are uniquely determined. So this is a partial game. Partial or impartial? Second round to end. Okay. So with odd numbers, are they like saying the position? Yeah, probably. Okay. So one odd, on even. So first of all, it is optimal for the first one to pass the potato to the second one. Afterward, only second one who belongs to the blue team hold a potato. Therefore, the score of red team is 1 by the score. So So we just need to count like how many of them what is the k value, is the maximum value is k is subject 10 to the 9. Okay, what happened for the second test case is like, yeah, the fourth one can pass to the next one. So I think it's always better to pass, isn't it? Yeah. If someone can pass, then why not? Like passing a value is always increase their score. Passing a value to the next one, to the next person is always increase their value. So why not? Isn't it always optimal to pass? I don't know. Here we have two moves. It's also saying like, okay, third test case is demonstrated here. It's round 1, round 2, round end. Okay. So in the initial round, all of them can pass, and they did that. Oh, okay. I see. So if there is consecutive values, like 3, 4, 5 has consecutive values, so the person who is in the position of 5 have the flexibility to hold all of them, right? It is always optimal for him to move him in the last, because if he move in the beginning, they definitely will move, so it will not increase in his score. So moving by 1 will only increase their score by 1, I think. Zero. Okay. Let's try to understand this just this. So 1, 2, 3, 4, 5, 6. I think I'll just write 1, 0. So the team of even and odd. So currently there is a consecutive elements, so the like odd team have the flexibility to whether they will move the piece or not. So it is always optimal for them to move this piece in the last, right? Like why not? Because if they move in the beginning or in the middle of the round, like they basically moving why? Moving because they can get a 1 more score. So they'll definitely move in the last, so that the person or the odd team do not have the option to move this to the next. So this is definitely will this. And then here, there is a consecutive once again. So 1 has the flexibility to do that. So there are like 1, 1, 1, 1, and I have 1 on 1. Like odd team has this flexibility. So there they will get okay. Like here the score of the ones group is basically number of consecutive elements. Let's say C is the number of consecutive elements is cons, so they will just get cons by 2 plus 1, right? Cons ones plus 2 plus 1 if it is even. What if it is odd? Then you plus this, yeah, then 3 by 2 1 plus 2, yeah, this is the same. Yeah, ones plus half by 2. So odd team basically getting 3 score here, and for the next consecutive 3 elements they're getting 2. 0 team is getting 1 and 1 again from that place. The play of 1. Oh, yeah. So here is 5 and here is 2. Now we are left with the elements which is at position 1 1. So who is okay, they also have the flexibility to whether they will move or not. So they will definitely will not move. So I feel like that the game is just one move. Just one move. Because they'll definitely never move if they have the option. So I feel like it's just one move. So I need to count number of consecutive elements. So to count it in a efficient way, how can I count it? I think I do this. Now whenever I get 0, I will start counting. No. Okay. So yeah, I think it depends on if S of I think there are 2 options, like if S of 0 equal 1 and S dot back equal 1. So the last and first will merge, otherwise they don't merge. If one of them have 0, then yeah. Also if all S of S dot back, if all of them are equal, then if S of 0 is equal to 0, then this is just like 0 0. Otherwise this is just, first is odd element, so this will be n plus 1 divided by 2 and that will be 2. So if both of them are equal, we'll count number of in the first and the last. Score 0 and score 1. No, right. E and odd, even and odd. So first we do this. Whenever we meet a 0, and S of I S of we'll start counting. equal n minus 1, that will definitely happen. So if I equal n plus 1, if first then total count, like count plus equal first count. If first count n1, if this is n1, then we add it to the odd. Like odd will be count divided by odd plus 1, and e is basically count minus count divided by plus 1. Else even plus is equal count divided by 1 plus 1, and 1 plus is equal count minus count divided by 2 plus 1. And in the other case, if I n 1, that means this is odd because we are considering 0 case indexing. Else even plus is equal count by 2 plus 1. What is else condition? What is else condition? I think we do not need the else. Wait, if first count is 0, if first count is 0, that means there is nothing in the first, so we need to basically calculate first is equal to n and 1, right? So otherwise, if the first start with 0, if the first start with 1 but the last do not have the zeros, then we have to consider the first separately. Like if s dot back equal 0 and first count is greater than 0, then if first count and 1, then we need to add odd plus is equal first count plus 1, and even plus is equal first count minus first count plus 1. Yes, so this is this. Let's see for the second test case. For the second test case, we are starting from n equal to 0. So I need to check like the count there. We never entered here. Why? So 5 plus 1 is 3. Count is equal 0, then we have I equal 0, I less than 1 minus. This is 1, otherwise we are counting. Why? What? Whoa, we have the, we should do n plus count is the same. Okay, now let's see the count. Count is 1, that's not true. 1 0 0 2 3 1. It should be 3 1. So why it should be 3 1? Because in the last there's only one of them, which will go to the first. So I can just check like even and odd here, and the even and odd here also, the first one. So that's true, like it goes to odd. Okay. Now we need to calculate this. Count is 3. From 3 of them, 2 will go to odd. 2 will go to odd. So I is equal to 4. That means this will go to no, I and 1. This is wrong. Everything is correct except the last one. Okay. First of all, we count this is there, like count. But we never entered here. At 11. So we are at 11. Okay. Yeah, then this will be I equal n. I think this time we are good. So let's just review once what we did. If the total number of zeros are, all of them are zeros, then we are basically taking half of them into on. Well, let's say we have 3 and only one more, which doesn't actually matter. And let's say zeros, 1 on 1. So that is basically what? It shouldn't be 0 0. Count of all tested back is equal to n. Oh wait, 3 3. Okay, that will be n by 2 because this is even, so we never do that. Then we are counting the even and odd. The first count we are adding this. Now we are starting from whenever we get a 0. So when we do not have any ones in the beginning, we are basically taking it also. We have okay. Counting this. So checking if this is odd, then we are taking it into odd, otherwise it is even. We are taking it into even, otherwise it is odd. Even, odd, even, odd. We have fixed it. Now if the first count is 1, the first count is 1. 2 2. Yeah, 2 2. never found a long farewell before leaves for the next mission. She says nothing and begins preparing a small ribbon for her instead. She places in glass bread in a row on the table. She places n-glass beads in a row on the table before threading them into the ribbon. Threading them. This bead is either. Okay, that's correct. She places n-glass in a row before threading them in one through the ribbon. Is bead is either white or black. A binary string S represent their colors. The character 0 represent a white bead and the characters 1 represent a black bead. To make the arrangement less ordinary, Neofriend turns it into a small game. She can perform the following operation any number of times, possibly 0. So choose a line such that both of them are equal. The current and reverse the following string. For example, if s is equal to 0, Neofriend may choose l is equal to 1 or is equal to 1. String becomes 0, 1 or 0. She places in glass. Okay. She can run the following operation. Choose. So number of different strings we can make by this reversing or this string. This is a string. Initially this. We can select this to move this one here. And we can move this one here as well. Okay, I think there is a number of arrangement of ones. We just can consider number of possible places of the consecutive ones because once we have consecutive ones, we cannot change them. So what I'm saying is that let's say we have 1 on 0. Let's say there is 0 and there is 1. There is a 1. Like my idea is that we can never change this 1 1. So I think we can just consider them as a single one. So if we consider them as a single one, we can move this one to here, which is almost equivalent to placing them this way. So if we just replace the double one into a single one, they're also kind of same, right? Yeah, that's the same. So I think we can just simply consider the number of consecutive ones we have, number of blocks of consecutive ones we have, and then number of places for them. We can just multiply them and that's the answer. But since it's a problem D, I to think about it a bit more. Let's see how many of them solved it though. Many of them. Probably not many of them. Is there any other way? Like, let's say we have let's say we have this and this and this. So now if we select this one and this one, we can reverse them. So what is happening here is this so my earlier claim was definitely wrong. Like we should definitely also we can make this, I guess. Okay, so if we are taking this is one possible representation of that screen, and another one is like if you select this one and this one, then also this middle string is changing. So this will be like 0 0 0 1 1 1. So it's also like we can just shift on of them, on of the string from that blocks to their adjacent block. Is that only adjacent block? Let's just consider more block. Like we have 1 on 1, then this is 0 0 1 0 0 1 on 1. So now if we consider this one and this one, yeah, we are still like shifting this one into this place. So one of the observation is like we can transfer one or multiple ones from a block to another block, but the number of ones must be less than its size. Okay. So this we have this 1, then 0 0 0. And so previously we have some zeros, and there's some ones, and there's 1 of 0. So what is happening now? Like if we select this 0, and then maybe this 0, we are selecting this 0 0 or these zeros. Yeah, there is no other way. There is definitely no other way to, when there is a single block of 1, we can never transfer it to another block, right? Yeah, it's definitely true. So you can only transfer amount of pawns with a less than or is equal the block size, less than the block size. What is the other condition we have made? Oh, we was like thinking how many such shifting we can make, or how many such a position for a particular block. So I think we need to count two things, like for a particular block, what is its maximum size, and the minimum size, so that we can find like how many times we are modifying this, and the number of places if we consider it by single one. I think we just need to count this. So this see this idea. I want to apply this idea to a random test case. If it is true, then I'll try to prove this. So let's say we have 1 1 0 1 0 0 1 1 0. So let's say this test case. Now, considering the blocks of ones into a single one. So for the first one, we can definitely shift this one to this position or this position. This is like the border ones. We can definitely shift this one into any place within this border. So there are like 3 options for this block, this one, right? 3 options, and it also have the three options. But there is a problem, like when we are shifting this one to this place, we cannot shift this to this place, right? So there are 3 options for this guy, but not necessarily 3 options for this guy. So this is considered simple test case. So in replacing this, it has only 2 options. So like 3 options plus 3 options but 2 options. It's like number of permutations of one. So one can be here, this guy can be here, how to calculate this number of position efficiently. How to this one there are 3 options. For this guy there is 3 options as well. But there is a common point for them, common adjacent point where they cannot cannot merge, cannot stay at the same time. So I think it's just like 3 into 2 plus, or maybe 3 into 3 minus 3 plus 1. So it's like Wes 1 or Wes L, let's say WL into WR minus I think it is like WR minus 1. So WL into WR minus 1. And then it is added like WL plus WL minus 1. Yeah. If we do that, then the total number of ways will be like 3 into 3 into 2 plus 2, this is 8, and again like 8 into 3 plus 2, 2 plus not 2, 7. Can we calculate this place using dp? I think we do not need dp here. I'll calculate this using dt, because that's intuitive. Yeah, we just need to kind of like keep track of whether we are having that one into the last position or not. So once we calculate the number of arrangement, we just need to calculate number of now sizes of them.
57009.
So for a particular one, there are kind of size of if there is a single one, let's have this. Now when we are shifting one of the ones here by selecting this and this, we are also changing their arrangement. So I think that doesn't matter. I think that doesn't matter, because shifting the one definitely does change their order. So I don't know. Yeah. Does it actually matter? This is 0, 1, 1, 0. So when we are shifting this one here, we cannot shift it here though. We cannot shift it here, can we? Yeah, we can. We can. So we need to count the number of. There's something with the number of consecutive elements only. There's something with the number of consecutive elements. I think we can. It's like we can permute them at. So let's just like C1, C2, C3, C4. Is like the number of consecutive elements like this. Elements block size. We are only considering ones. So it is like this is sum is equal total ones. So it's like x1 plus x2 plus x3 and x4 must be equal sum, and the x1 and the xi, which are 1, can change. We can shift them into any place. Oh, like we can do this. We can subtract one from all of them. So we can subtract one from all of them. Then it's like the modified sum, and E6 must be equal to 0. Still we cannot consider those consecutive ones which are a single one block, because we can never pass an element there, right? Is there an easier way to find this? If any of them is 0, we'll just put, yeah, one of them can be a 1 though. Now we'll just do this later, but now we have like consecutive ones even. False, right? And only if it's greater than 1. And we also do the sum. Now we need to do the stars and bars. And also we need to count the ways. Wes and Cal. Cal is like m comma sum. M is the number of variables and S is the sum. I'll calculate both of them. Cal is, just use the modular here. We definitely don't need this. So stars and bars. Stars and bars is like, let me check out my notebooks. n identical items into k distinct bins. N identical items into k distinct bins. So it is n plus k. So I think we can just replace this with C of m plus sum minus 1 comma k distinct bins, which is m minus 1. Right. And the width I think we do not need to calculate width. I think using dp is imperative. So I'll just use a dp. Right. What does mean by last? If I put it in the value in the last row. So in T, I think we'll just store the else. So if I equal values to exercise on m0, where's the multiplication? Total length. What is the length? It is like if I equals 0, then 0, otherwise let's just calculate it more easily. Like left is 0, right is 0. If I equals 0, then left is not 0, then left is equal values of I minus 1. I think values of I minus values of I minus 1 is the number of ones in the middle, right? And if I is not right plus is equal if it is 0, then left plus is equal to values of I exist. Yeah, values of I is 0% exist, so that's just simply saying that number of zeros in the left. If it is not the last element, then we can also calculate the right side, like values of I, else else it will be like r plus is equal to n minus values of I. Yeah, minus 1. So in len will be left plus, right? So len is basically saying number of total values in left or right. So now if L, that means there is a last element. So self null rate len minus, what is that? Len minus 1. Mul of len minus 1, comma drop I plus 1, and number of position is like len minus 2. Len minus 2 says that we are not placing in the last, so it is 0. Also self null will be red comma mul of. This will be, yeah, this will be just replacing the last one. If it is not nothing in the last, then I think it's this len minus 1, because there is a replace option. Return bp of I comma else will get. This is completely wrong. This is just 0, nothing, right? This is wrong because the left right ways we are calculating is wrong. This is wrong. So I think I'll just add t here as well. So this is not actually n, this will be size 1. Size minus we also have. We also have 0. Minus 1. Lane is 0 here. Right. Left is 0, right is 0, lane is minus 1. No, lane is 0 here. Not, lane cannot be 0 as well. Lane will be 1. So what is left? Left is 0. But in the left, oh I see, it will be left plus right plus 1. In the left is calculating number of zeros. Number of zeros, if there is no zeros. There are two such a position, right? I think my mistake is calculation in the left right. How many options for a particular element in the left? This is basically a number of zeros in the left. Yeah, there's basically a number of zeros in the left. This includes itself, right? Because we cannot take the last zero. So if it is in the so 0 minus n is giving n minus n minus 1. lane is -1. Number of zeros in the left. Number of zeros in the left is not 0. Well, why is basically 0? It's no zeros. No, it's +1. It's +1. Left is 3, that is true. Right is 2, that is also true. Left is 3, left should be 2. Number of zeros in the left is +1, like including itself is 2, so 0 and 2. Right is 2, right is left 1. Okay, now left is basically meaning how many zeros out there. If there's 2 zeros, if there's 2 zeros, we are subtracting one of the zeros, so I think it will be like if left is equal to 0, there should be 1. If right is equal to 0, right should be 1. Yeah, like there is not a way. 201 now. Yes, 5. Is it true? It's definitely not true. It says 3. Shit, man, this target calculating is simple math. Okay. Yeah, my calculation is wrong here. I need to actually think another way. My calculation is definitely wrong here. This is completely wrong. It's bullshit. That's bullshit. Okay. Anyway. Let's say we have like zeros and zeros and zeros. Oh, I think it also can be solved using combinatorics. Well, now it is. That's true. And consecutive zeros. So zeros also can be in any number, but there must be at least one. So you can. This is the same. This is the same thing. You can just do it for the zeros. What the hell? we'll just repeat that twice, or make a function. It just took me so long to solve that. Oh shit. Or any of them. probably me. This is a runtime communication problem as the virus Nigelato prepared an unusual game for these people. They would be separated and unable to exchange a single word. Between them, there would be only a black and white picture. Okay. They would shift, rotate, reflect on inverse color. Saw it as a test of how well they understood each other. Cothley and Willie perhaps saw only another kind of promise. No matter how the world turned, they would still find the same place. The two players are Cothley and Willie. Zari acting as this first communication. What the hell of his name? Okay, let me rename them. I'll just use the first word. So first communication starts with C, or maybe Sith and Nig. So after Sith finishes, the Jari communicates with the Willie. Sith and William may agree on the strategy they will use beforehand, but they cannot directly pass information to each other. In each case, Nick prepare a black and white picture consist of n by n cells and chooses a target cell X, the rows and columns from one trend. The picture contains W black cells. It is guaranteed that any format of this one. So long. So it is basically cyclically shifting them in the forward. Oh no, it can be 0. If it is 0, then wait, what? The RDC, so it's plus. Oh, lastly it's plus also. They are basically cyclically shifting. Rotate the pixel by 90 degree. Once it's rotation, every cell RC becomes this. Refer to the picture. Across its particular axis, the reflection mode is the opposite of clockwise rotation. Invert on current. This changes every cell. The target cell X undergoes every cyclic shift, rotation, and reflection in exactly the same way as the pixel. Color inversion do not move it. Finally, it shows only the resulting picture too. We must determine the final position of X. Wait, what? Seriously? How it is possible? Final position of X. Okay, so it's like there is a target cell X, and X will be shown to the first player, and first player can swap any two cell. So after that, the middleman can do cyclic shifts, or like he can rotate, reflect, or invert all the color cells. The target cell X undergoes every cyclic shift, rotation, and reflection. Color inversion do not move it, so target cell. W is the number of black cells. Okay. Black cells. now is x. It's easy to write. Let's have this. Now, as a first person, what strategy I can do with the second person so that we can figure it out? Like, let's say, does they guarantee that it is always possible? How? I mean, they're actually guaranteeing that, I think. Why did they guarantee? Yeah, they're guaranteeing. So let's say I did nothing. Okay. Exactly did nothing, and yeah, like if we like if the first player do nothing, it doesn't make any sense. The first player must do something to the grid so that there is a strategy to figure it out. I think. There is also need some observation, like how the rotation cyclic shift works, like what make changes by doing it. dr and dc, um, dr and dc cyclically shift the pixel every cell. Okay, we're basically shifting every cell, not a single cell. So you're kind of rotating the entire grid or entire picture. Okay, that's still fine. And we can also rotate the picture by 90 degrees. That just changes the. Okay, by changing it 90 degrees, we are just kind of. What makes it sense? Also, you can reflect. Reflecting means we are just mirroring the column's color. Then we can also invert the colors. We can easily understand if the colors inverted or not. That's fine. Is it always? Is it always possible? I don't know. This problem is look like hopeless. I think I should try the last one instead of this. Yeah, this looks nice. Before her final sortie, Claudia asks Willie 3 questions. The first is this: is the end is inevitable? How long will it take until nothing remains? William cannot answer her directly. Instead, he writes down n positive integers. Each operation takes 1 second. In operation will it does the following. Choose an index p. Then replace a of p by this for every I except p. Replace a p and for this but oh okay, this is a floor division, this is solution. So by doing the floor division we are basically removing the last bit no matter if it is 0 or 1. By doing the cell division we are removing the last bit if it is 0, otherwise if it is 1 we are making it 0. Is that like we have 3, we divided by this, we have 5, we divided by 2, seal that is 3. No, like we are still removing but carrying 1 I think. Dividing an integer by 2, seal division. What if no, no. It's like 1. Let's see. 7 divided by 2 is 4. Still 1 0 0. Okay, this is 0 1. This is 8 to 1. 11. 11 divided by 2 is 6. 6 is 1 0. Okay, it's like removing the last bit but carrying 1. So you're adding 1 in the binary of that shifted element. So if a particular element is currently minus 1, maybe 1, it's probably depend on the consecutive number of set bits in a number. Because if there are like consecutive number of so it's like we are given some string in this form. Like for the first case it is 2 1 3, then definitely optimal to use floor division here, I think. Oh wait, not necessarily. This number of moves will not exceed, I think, 60 maybe. Yeah, because there can be at most 30 consecutive ones, so 30 consecutive ones means there can be 1 0 1 0 1 0 1 0 this way. 1. So if we delete this, we will end up this. If we delete this, we will end up this. So every time basically we are removing this, we add 1. Remove this, we add 1. Simply ignore them. So if we take the more operations, we at least do remove them. It's like there are kind of some intervals. There's kind of an interval. So with our remaining element, we must actually do because remember we don't want than 1 1 3, right? Then here it is 6. So definitely removing all of them is better. I think then we should use a DP. We're given some string of length 30. Yeah. take less than. বাকি তো 11টা বাজলে শেষ হয়ে যাবে। How can I say? When we have that amount of operation, I can. How can I do DP here? Where's the maximum number of operation? Yeah, it's like we will select a particular string and a position, and we do the number of operation on that particular string equal to the number of consecutive ones, right? So the number of operation I think will not exceed I don't know. We can do n log n at most here. Select a position of a string and then we fix the position, we do that amount of consecutive. Other than that, when we are doing that amount of consecutive, the other string will also shrink. So or is there any greedy way to figure out? Okay, let's say we have some string of this one. So what do you do here? I think it's always optimal to select the leftmost ones which have the minimum amount of. So I think I will do gray. I will do gray. I'm not sure if it will work or not. Since there is only 12 minutes and I'm trying out if I probably just have some wrong answer, that's not a problem. So we also keep li. Li is equal to n. If we sort them, then it will be n log n square. We're gonna sort them. Of the greater length. Is it the minimum length? I'll just definitely choose it. We set the minimum length. How can I count the minimum length here? What is the bitwise technique to count the minimum length? I'll do brute force first. Let's say car length, gate length. Okay. So length greater than car length, the length is equal car length and who is equal I. Brother, will it give us runtime error? Let's see. Let's first run this. No way. No way. Is minus on? What I'm doing? তুমি আসলে শুয়ে পড়ছো? মাশাআল্লাহ। সাবাস। Why not just do it? How this is one? Bro, each operation take on. In also option you can select and select replace this with it. Hours 3. There's another zero only. Yeah. Oh, okay, yeah, that's true. That's true. What? No way, bro. Oh, we at least need n amount of operations. In the last, we at least miss n amount of operation. Zero. That's right. First one is true. Okay.